Two men are standing on the ground on two sides of a pole. The angles of elevation of the top of the pole as observed by the men are 30 degrees and 45 degrees respectively. If the height of the pole is 100 meters, what is the distance between the two men? Okay, so this segment AB is the pole, we can assume that, which is of 100 meters. Right, and this C and D are the two men standing on two opposite sides of the pole. Now, the top of this pole, that is this A, makes an angle of elevation with C as well as D. These angles of elevations are 30 degrees and 45 degrees. So we can say that this is 30 degrees and this angle is 45 degrees, right? What we want is the distance between the two men, that is CB plus BD, right? We want this. So we can take tan 30 and tan 45. Let's take tan 30. So tan 30 is equals to opposite upon the adjacent, that's 100 upon CB, right? So tan 30 is actually 1 by root 3 from the trigonometric table. So this is 1 by root 3 is equals to 100 by CB, right? So I can say CB is equals to 100 times root 3. So I've got CB. Now I can take tan 45. So tan 45 is equals to opposite upon adjacent. So opposite side is 100 meters long upon the adjacent side, which is BD. So tan 45 from the trigonometric table is 1. So this is 1 is equals to 100 by BD. So I can say BD is equals to 100. So we've got the value of CB and BD. We can calculate their addition. So CB is equals to 100 times root 3. We can calculate that 100 times root 3 is 1.73. So this is basically 173. So we have 173 plus 100, right? 100 plus 173 is 273 meters. So the distance between these two men is 273 meters, and that is option C. A man standing at a point P is watching the top of a tower which makes an angle of elevation of 30 degrees with the man's eye. The man walks some distance towards the tower to watch its top, and the angle of elevation becomes 60 degrees. What is the distance between the base of the tower and the point P? So we have a tower standing on the ground, and this is the point P where the man is standing, and he is looking at the top of this tower, and the top of this tower makes an angle of elevation of 30 degrees with the man's eye. So I can say that this angle is 30 degrees, right? Now the man walks some distance towards the tower. Let's say he walks some distance and he reaches here, this point. Let's say it is P1. Now the angle of elevation becomes 60 degrees. So this angle of elevation is now 60 degrees, right? Now we have been asked what is the distance between the base of the tower and the point P. So we have been asked this distance, complete distance between the base of the tower and point P. Well, what do you think? Can we calculate that? We could have calculated that had we be given this height of the tower, or at least the horizontal distance, but none of it is given, so we cannot go ahead and solve this question, right? So the data is inadequate in this question, and that's option D. The angle of elevation of the top of a tower from a certain point is 30 degrees. If the observer moves 20 meters towards the tower, the angle of elevation of the top of the tower increases by 15. What is the height of the tower? Okay, so this is our tower and this is the point, let's say P. Now the angle of elevation is 30 degrees from P. So this angle is 30 degrees, right? Now this observer moves ahead towards the tower and the distance moved is 20 meters. Let's say he reaches here, P1, and the distance traveled is 20 meters, right? Now the angle of elevation has increased by 15 degrees. So this angle is now 30 plus 15, and that is 45 degrees now. Okay, and we have been asked what is the height of the tower. Let's say h is the height of this tower, and let this distance be x between the point P1 and the base of the tower, right? So we have tan of 30 is equals to opposite upon adjacent. So let me write it. Tan of 30 is equals to the opposite side is h upon the adjacent side is 20 plus x, isn't it? So this is 20 plus x. Now if we take the tan of 45, we get, let us write it, tan 45 is equals to opposite again is h divided by the adjacent side, that is this x, right? So let us solve this. Tan 30 according to the trigonometric table is 1 by root 3. So this is equals to h upon 20 plus x, right? Let us solve this further. We have 20 plus x is equals to h root 3, right? So x is equals to h root 3 minus 20. This is one equation that we've got. Let us solve this further. Tan 45 according to the trigonometric table is 1. So we have 1 is equals to h by x. So therefore x is equals to h, right? Now the left hand sides of these two equations are same, so we can equate them. So I can write h is equals to h root 3 minus 20, isn't it? So 20 is equals to h root 3 minus h, correct? So therefore h is equals to 20 divided by root 3 minus 1, isn't it? Well, let us make this more fun. We can multiply this by root 3 plus 1 upon root 3 plus 1. Essentially the value does not change. So we did this because we want to get rid of a root in the denominator, right? So this is equal to, I have, let me write it here, equals to, I have 20 root 3 plus 20 upon a plus b into a minus b, isn't it? That's a square minus b square. So root 3 square is 3 minus 1 square is 1. Okay, so this is equal to 20 root 3 plus 20 divided by 2, and if I divide this by 2, I get 10 root 3 plus 10. And what is root 3? Root 3 is 1.73. So this is 17.3. If I multiply 1.73 by 10, I get 17.3. This is plus 10, and that is 27.3. So the height of this tower is 27.3 meters, and that is option C.